Okay, so let's look at graphing our cosecant and our secant functions here. So, you already told me that this is a graph of sine, right? So cosecant at 0, is not going to be 0 anymore, but it's the reciprocal, right? So it's 1 over 0, so it's going to be what? Undefined. Okay. What about cosecant of pi over 6? So pi over 6 is just a positive 2. Yep, because sine is 1/2, right? Okay. And then what happens when we do cosecant of pi over 2? That's going to be a what? A 1. Cosecant of 5 pi over 6 is going to be what? A 2. Cosecant of pi is going to be what? Undefined. Cosecant of 7 pi over 6 is going to be what? Negative 2. Cosecant of 3 pi over 2 is going to be what? Negative 1. Cosecant of 11 pi over 6 is going to also be a what? Negative 2. And then 2 pi, we're going to be back at what? Undefined. Okay, so let's graph it on this sine curve. Yes? So I'm going to graph it on the sine curve. So what does it mean to be undefined? What am I going to have there? An asymptote. Yes, I'm going to have a vertical asymptote. Okay, so vertical asymptotes there. I'm undefined. So I'm going to be undefined at 0. Again, at what? Pi. And also at 2 pi. Yes? Okay, so at pi over 2, I'm going to be at 1. And on either side of pi over 2, so at pi over 6 and then 5 pi over 6, I am going to be up at 2. So what do you think that this graph then is going to do? What do you do when do you ever cross an asymptote? Well, that's a convoluted question, but because sometimes you do. Yes, so do you always cross an asymptote? No, but you get what to it? You get really, really close to it, yes? So you're going to get really close to it, so it's going to look like a U, yes? Okay. So 3 pi over 2. So at 3 pi over 2, I'm going to be at negative 1. And then on either side of 3 pi over 2, I'm going to be at a negative 2. Yes? So what's going to happen here? I'm going to be a what? I'm going to open down, yes? So take away the red graph. So this is the graph of cosecant. So this is the graph of cosecant, yes? Does that make sense? Okay, so all we did was just take sine and do what? Do the reciprocals of it, yes? Just flip them around, yes? All right, so question 2. Oh, Where? Pi over 6. Oh, because sine of pi over 6 is what? 1/2. All right, so question 2 says, for what values of theta will the graph of cosecant have vertical asymptotes? Well, I already kind of gave that away, but so where are they going to have vertical asymptotes? 0, pi, and 2 pi, yes? For all the theta values, 0, pi, and 2 pi. So what does that mean? It's going to keep repeating, right? So every asymptote is going to fall at an interval of pi. Yes? Okay, so asymptotes are going to fall at intervals of, so we'll start at 0, and we'll add, not 2, I'm sorry. We'll call it n pi. So vertical asymptotes for cosecant will be any multiple of pi. So it can go in the negative direction or the positive direction, yes? Do what? I just drew that little dotted line. That's a dotted line right there. That is a vertical asymptote. So the dotted line represents the vertical asymptote. It is going to get close to that but it's never going to touch it. Okay? So far, so good? All right, and what values are theta, of theta, are cosecant and sine going to be equal to each other? Pi over 2. Good deal. So pi over 2 and 3 pi over 2. 5 pi over 2. Yes. Because they're what? Reciprocals. So reciprocals of 1 are just going to be 1. Yes. And negative 1. Okay. All right. And I already graphed that for you. Yes. Kind of skip that step there. So what is the range of y equals cosecant of theta? Is it going to be from, remember, so what is the range of sine? -1 to 1. So what is going to be the range of cosecant? So it's going to not be anywhere defined between -1 and what? 1, right? So if you look at it, it's going to go from -infinity up to what? -1. Good job. -infinity up to -1. And then from what? 1 to positive infinity. Good deal. Good deal. Okay. So, suppose we graphed y equals secant of theta. Name 3 vertical asymptotes between 0 and 3 pi. So, secant is going to be the what to cosine. So where are my asymptotes going to happen here? At where? At pi over 2? At 3 pi over 2? And what? 5 pi over 2. Yes? And we can keep going in either direction, right? So, suppose we graph secant. So my asymptotes are going to happen at values of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2. Okay, so how we say this is that they're going to have asymptotes starting at what? At pi over 2. They're not happening at every pi, but they're happening at every pi over 2. So what do I need to add to that pi over 2? So I need to add pi. Good deal. So I'll still be adding in pi here. Okay, so with the information that we just did, okay, so we drew our asymptotes. So so sine and cosine look identical, basically, right? Except for it's kind of a shift. So do you think secant and cosecant are going to look identical? Where they have the u's open and up and open and down. It's just where the asymptotes fall is going to be the different part about it, right? So that means that if I wanted to graph this, then what's going to happen? I'm going to have a point here, and what am I going to do? I'm going to go up. And then right here at pi, I'm going to be equal to -1. And then I'm going to open what? Down. And then at 2 pi, I'm going to be at a +1, and I'm going to open what? Up. So if I just drew that right there, that is one period of my graph. Do you see that? So it's one period of my graph. Even though it's kind of starting funny. Yes? So I'm starting at 0 and I'm going up. But what do we know that the other side's going to look like? It's going to be a U on the other side, right? So it's going to be opening up as well. So we can continue drawing the graph. You don't have to, I'm not looking for that it's cut off like I just did. So we could keep going and draw that side of it. But 2 pi is the period, okay? Just like for our sine and cosine curves, 2 pi is our period, okay? And same thing over here, this would be what, negative pi over 2? So if it was negative pi over 2 over here, then that would be an asymptote, and I could finish my graph there. And we would keep repeating this pattern, right? It's periodic as well, so this pattern would be identical. Good? So 8, I just gave 8 away. So what is the period of cosecant and secant? 2 pi, yes. So 2 pi. So it's going to be the same as what? Sine and? Good deal. No. Mm-mm. Well, the range of secant will be the same as cosecant.
Yeah.
Mm-hmm. Yep. Sorry, I thought you meant of sine and cosine. So, good? Does that make sense? So far, so good? All right, so let's kind of put everything together a little bit. So let's look at cosecant. So cosecant is going to be the reciprocal of what? Of sine, yes. So remember what your sine values are. So they're 0, 1, 0, -1, 0, right? Okay. So if we can remember what our sine values are, our cosecant values on our tables if we were to graph. Okay, so let's think about sine. So sine of 0 is what? Is 0. So cosecant of 0 is going to be what? Undefined. Sine of pi over 2 is a 1. Cosecant of pi over 2 is going to be a 1. Sine of pi is 0. Cosecant of pi will be what? Undefined. Cosecant of 3 pi over 2 will be a what? -1. And then cosecant of 2 pi will be undefined. Good? Okay, so the period is going to be what? It's 2 pi. And where do my asymptotes happen here? Everywhere I'm undefined, right? So every pi value, basically. Okay, so let's graph this on. So we'll have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So it's periodic. It's going to continue, right? Okay, in a pattern. So at 0, we're going to be undefined. So that's going to be a what? Asymptote. So we draw a little dotted line. So we'll draw a dotted line at pi. And we'll draw another dotted line at what? At 2 pi. Okay. So at pi over 2, we're going to be up at what? At 1. And at 3 pi over 2, we're going to be where? Down at -1. So we're going to have a u going towards our asymptotes, going towards infinity. So we're going to go up. So if you can imagine that sine graph fitting in between there. Basically at the peaks, we're going to be opening up, and the valleys, we're going to be opening down. Okay? All right. So secant of x is the reciprocal of what? Cosine. The period is still going to be what? 2 pi. And the asymptotes are happening differently. They happen at intervals of pi over 2. Okay, so secant of 0 is going to be a what? 1, perfect. Secant of pi over 2 is going to be undefined. Secant of pi, -1. Secant of 3 pi over 2, undefined. Secant of 2 pi, be 1. I mean, we can follow this pattern all the way through, yes? Okay. So it's just going to be a shift a little bit. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So my asymptotes are happening at intervals of pi over 2. So if we can graph sine and cosine, we can graph cosecant, cos and secant. Okay. All right. So at 0, we're going to be opening what? Up. At pi, what are we going to do? Up and down. And at 2 pi, we're going to be opening up. So that actually represents one full period of the graph of secant. But you know that it does have another side, right? It's got a U-shaped graph. So it continues. Does that make sense? Y'all have questions about this? Y'all feel okay? Okay. So if we did transformations of secant and cosecant, the same thing is going to happen. We're going to have our A, and I'll just put cosecant here, and our B in the inside, so they all change the same ways. Yes? So it all changes the same, just like sine and cosine changes, same thing happens with cosecant and secant. Remember, I showed you how to use your table. You don't have to use your table to graph, but it does kind of help a little bit to do that. Okay, so y'all try 1, 2, and 3 for me. Okay, so let's look at the first one. So it's secant of 3x. Okay, so I'm looking at secant. So what is going to be my period here? So my period is going to be 2 pi divided by what? 2 pi divided by b, which is 3, yes? So my period is going to be 2 pi over what? 3. So what did I just do to this graph? Did I stretch it out or did I shrink it? I shrunk it, yes? Okay. So let's talk about our x then and our y values here. Whoops. I don't want to put y so close. Sorry. So secant will be at 0, pi over 2, pi, 3 pi over 2, and then again at 2 pi. What does b change? X. So I'm going to multiply the x values by not just 3, but I'm going to multiply by what? 1 over 3. Awesome. So they're reciprocal. So I'm going to multiply by 1 over 3. Perfect. Good. Okay. I don't have a c, right? So do I need to worry about adding or subtracting a value to that? Nope. So now let's just go ahead and do our normal y values. Sorry, my table's kind of running into the second question here. But my normal y values, so secant, my normal secant values are right here. Right? So I need to remember those. So at 0, we're normally at what? 1. At pi over 2, we're normally what? Undefined. At pi, we are at -1. At 3 pi over 2, we are back to undefined. And then 2 pi, we are at 1 normally. Do I have anything that will change my y values here? I do not, right? Okay, so all I need to do is just multiply all the x values by 1/3. So I'm shrinking it up, yes? So I still will start at 0. But here, instead of my next value being at pi over 2, I'm going to be at pi over what? 6. Good deal. Okay. At pi, instead of being at pi, I'll be at what? Pi over 3. 3 pi over 2, I will be at what? Pi over 2. And then at 2 pi, I will technically be at 2 pi over 3. And what does that number tell me right there? That is my full what? Period, right? Because my period is 2 pi over 3. Does that make sense? Make sense? So just like you're dividing, technically you're just dividing by the whole number b. So you are multiplying by the reciprocal. So, because remember, if it's a whole number inside of here, it's going to shrink it. So we're going to multiply by the reciprocal of 3, which is a 1/3. Okay? And just like C, if it's a negative inside there, we're going to add. If there's a positive inside there, we're going to subtract. So we always do the opposite. Mm-hmm.
And that goes for sine and cosine.
It sure does. Mm-hmm. Okay. So we'll be at 0. So now I'm going to scrunch it up a little bit. I'm not very good at scrunching when I have to draw my own table. Okay. So at 0, we're going to be up at 1. At pi over 6, we're going to be where? Undefined. At pi over 3, I'm going to be at a -1. At pi over 2, I'm going to be undefined. And then at 2 pi over 3, I'm going to be up at +1. So my graph is going to open up, open down, and then open up. And like I said, I did not do very good scrunching it, really and truly, but it is going to be scrunched inside there. Okay, so look at how your asymptotes changed here. Normally the asymptotes happen at intervals of what? Pi over 2, right? So now they're at intervals of pi over 6. Good. Pi over 6. Good. Okay. So what about for number 2? So write an equation for a cosecant curve with asymptotes at x equals pi over 4, x equals pi over 2, and x equals 3 pi over 4. So cosecant. So if I'm going to change my asymptotes, that means I have to have what inside there? A 2? Okay, so if I'm going to change my asymptotes, just like I changed my asymptotes for that secant one, what letter am I going to have? B, good deal. So I'm going to have some B right there, inside there, for sure. Now what is that B going to be? So, a whole number, so it's going to be a whole number. So my first asymptote happens at pi over 4. Where does your first cosecant asymptote happen? At 0. Yes?
Oh, yeah.
Yeah? Okay. And then your next one happens where? At pi. Okay. And then your next one happens where?
2 pi.
At 2 pi. Okay. So what do you think I did right here to this to get a 4? Did I divide by something here? What did I divide by? A 4. Yeah? Divided by a 4. And what about right there? 2 pi divided by what? What is that going to give me? Pi over 2. So what should B be? 4. Awesome. Yes? Okay, so let's look at number 3. So write an equation for each of the graphs below. Oh my goodness. Okay, so for the first one, let's look at where my asymptotes are going to fall. Looks like pi over 2, right? Okay, so what type of function am I looking at? Secant, yes. Okay. All right, so, but secant usually does not open down right here, does it? Nope. What does it usually do? It opens up, right? Okay. So what do I need to put out on the front? So nothing else changed, right? So that's a 1. That's still a 1, or a negative 1, I'm sorry. That's a negative 1, and that's a what? Positive 1, right? So nothing's changed other than I flipped it, right? So I flipped it around, so that means that this needs to have a what on the outside? Good deal.
It would also be secant x would be a +4.
So nothing really happened with our asymptotes. It could be maybe plus a pi inside there for that one. Uh-oh. So it could be, if you wanted to think about it, starting right there, that it shifted. It had a phase shift of a pi. You see that? So it could have been secant of x minus a pi, if you wanted to say that. Yeah. Does that make sense? Okay. All right, what about for B? So where does my asymptote look like it's fallen? At 0. So which one of those has an asymptote at 0? So this is going to hopefully be a cosecant function. But what did I do to my midline here? I shifted what? I shifted up. How many? 2?
Yeah.
Looks like 2, right? And I didn't do anything else, did I? Because it looks like it's 1 away from that midline, right? On both of those. It's 1 away, just 1 unit away, right? So I didn't do anything else. I didn't stretch it either. I just shifted it up 2. So this will be cosecant of just x, and then plus a 2. Good? Does that make sense? Okay. All right.